All right, problem 2-56. A dart hits each of these dartboards at random. What is the probability that the dart will land in the unshaded area? So we've got these two dartboards here. This one has this inner circle that has a radius of 2, and then we have this larger circle around the outside that has a radius of 2 plus 2 or 4. So when we're looking at coming up with probability of the dart hitting the board in a certain location, we're going to be looking at the geometric probabilities here. So we're going to be comparing the areas of these regions that satisfy the situation versus the entire area of the board. So for instance, on this first one, if we want to figure out the area that of the unshaded region, that would be this little circle here. So remember, area is going to equal pi times the radius squared for a circle. So if we can take our small circle and its area, and we're going to compare it to the area of the entire board here. So we're going to do the small area, or the small circle's area, over the entire area. So let's take a look. The area of the small circle is going to be pi times our radius, which is 2, squared. And our area of the entire board here is going to be a radius of 4, so we're going to have pi. Sorry, my pi's aren't looking real sharp there. Times 4 squared, in which case we get 4 times pi in the top, because 2 squared is 4 times pi is 4 pi. And on the bottom, 4 squared is 16 times pi gives us 16 pi. Now, we're not completely finished because we have common factors in the numerator and denominator. So just like if you were to do a probability problem where you're taking something out of a bag and talking about what's the probability you would pull a specific item out, we have to take this and reduce this down like we would with one of those. So pi is a factor in each of them. So our pi's actually cancel out. I'll do that in a different color so it stands out. And then 4 over 16 is actually equal to 1/4. So our probability that the dart would hit the unshaded region is 1/4. Let's look now at the second one. What is the probability it's going to land in this region? So we're going to have to, first of all, look at it as trying to come up with the area of this part first. To get the area of the unshaded region, okay, we are going to subtract the area of the small circle from the area of this middle circle. So let's put middle circle area minus the small circle's area. So our middle circle's area here is going to be 2, 4. So our radius is 4. So we have 4 squared times pi, which is going to be, or actually let's just write it in there. Pi times 4 squared, which is 16 pi. For our small circle, we've got pi times 2 squared, which is going to be 4 pi. And when we subtract them, we get 12 pi. That is the area of the unshaded region. Now that we know that this is an area of 12 pi, we can figure out what the entire area is going to be, and then we can compare them using the ratio. So Our large circle is going to be an area of pi times 6 squared. So we're going to get 36 pi there. That's the area of the entire thing. So if we want to come up with that geometric probability here, we're going to take the area of the region here that satisfies what we're talking about compared to the entire thing. So we're going to do 12 pi over 36 pi, in which case, once again, our pi's are going to cancel, and then you have 12/36, which is the same thing as 1/3. So if you throw 3 darts, one of them theoretically should land in this region. That's it for problem 2-56. If you have additional questions, make sure you ask your teacher there. This one can be tricky. It can be even trickier if you start turning all of your pi values into decimals. So I would highly encourage you to leave pi in your expressions. That's it. Thanks for watching.